Have you ever taken off and someone thought, why does my airplane feel heavier? That's due to density altitude. In this video, let's break it down, what it is, why we use it, and how we could calculate it. We use density altitude to gauge aircraft performance in a specific environment. It's defined as pressure altitude corrected for non-standard temperature. To understand that definition, we first must break down what pressure altitude is and what makes the temperature non-standard. Pressure altitude is your height above the standard datum plane. You could see this altitude on your altimeter when you set your altimeter's Kosman window to 29.92 inches of mercury, which is a standard sea level pressure. Non-standard temperature implies that there's a standard temperature. The standard temperature at sea level is 15 degrees Celsius or 59 degrees Fahrenheit. When the environment has these standard pressure and temperature values present, we call it a standard day. As the outside air temperature increases, density altitude also increases. Higher humidity and lower pressure also push density altitude higher. And as density altitude rises, aircraft performance drops. This is because the propeller produces less thrust and thinner air, the engine makes less power, and the airplane simply doesn't perform as well as it would at lower density altitudes. Now let's walk through a density altitude calculation. In this question, we are finding the effect of a temperature increase on the density altitude from 25 degrees Fahrenheit to 50 degrees Fahrenheit with a pressure altitude of 5,000 feet. First, let's pull up figure number 8. You'll notice on the titles we have density altitude, outside air temperature, and then in the middle of the chart we have pressure altitude. Now let's start by finding the density altitude for 25 degrees Fahrenheit. On the bottom of your chart, find 25 degrees Fahrenheit. Trace that line up until it intersects with the pressure altitude of 5,000 feet. From there, follow that line to the left, and that would be your approximate density altitude. I got 3,800 feet. Now let's do the same thing with 50 degrees Fahrenheit. I got approximately 5,400 feet. Now subtract the difference between the two and you get about 1,600 feet. Scanning through the answers, the closest one is letter C at 1,650 feet. Let's try another practice problem. This time we're going to find density altitude for a specific altimeter setting. This problem gives us an altimeter setting of 29.25, a runway surface temperature of 81 degrees Fahrenheit, and an airport elevation of 5,250 feet mean sea level. First, start by pulling up figure 8 again. This time we're going to use the chart on the right side showing the altimeter setting and the pressure altitude conversion factor. Looking at the altimeter settings, you could see that we do not have 29.25 as an option, but we have 29.3 and 29.2. So we're going to have to interpolate between the two to find the conversion factor for 29.25. Looking at 29.3, we get a conversion factor of 579 feet. And then 29.2 is 673 feet. The difference between the two of these is 94. And since 29.25 is only halfway between the two, we could simply divide 94 by 2, and you'll get 47. Notice on the chart how as the altimeter setting increases, the conversion factor decreases in feet. So you're going to want to subtract the 47 from the conversion factor of 29.2, which is 673 minus 47, and you get an answer of 600, 626 for an altimeter setting of 29.25. So that's going to be your conversion factor. Next, you're going to want to add that conversion factor to the airport elevation of 5,250. And this will give you your push altitude. Adding these together, you'll get 5,876. And that would be your push altitude. Now you can start finding your density altitude by the same means as the previous problem. We'll use the runway temperature of 81 degrees Fahrenheit. We'll go at the bottom of the graph and find that. Trace the line up till we intersect with a pressure altitude of 5,876. And from there, we'll look to the left and follow that all the way to the left. And we'll get approximately a density altitude of 8,400 feet. Going back to the question, looking at all our answer choices, choice C is going to be our closest choice, so we'll select that. Thank you guys for all your support, and don't forget to like, comment, and subscribe. I'll also leave a link down below to the King's School free private pilot practice test. I'll also leave a link to the book I used to study. Thank you.